today's lesson is going to be 12.1. It's on relations and functions. So let's just jump right in. We have some definitions that we're going to talk about. First one is a relation. A relation is any set of ordered pairs. You should know this by an x, y, so that's what we're talking about as an ordered pair, plotting it on a Cartesian plane, coordinate grid and stuff. So the second definition that we need is a function. A function is a relation, using the previous word, in which each element of the domain corresponds to exactly one element in the range. Okay. We're going to use a vertical line test, which is the next thing we're talking about. And the vertical line test is to help us tell if something is going to be a one-to-one function. So no vertical line can intersect a graph more than once, only one time, if the graph represents a function. If I'm going too quickly, then you just need to pause this video and write them down. The domain is the set of all values of the independent variable x. So the domain is a set of all x's, whereas the range is the set of all values of the dependent variable y. So you'll see that a range has to depend on the x values. So that's why it's dependent for it. Now we jump into some questions. So we need to take a look at what we have here. And the first one has a set of x and y's. So your x's are your 4, your -2, 6, 4, and -1. It said for it to be a function, all the x values have to be different y values. So if we look here, we have a 4, 1. We're okay in the set. -2 is 3. We're good. 6 is 3. We're still okay, even though they see the same y value. But then the next one here, so this 4 should have an answer of what? This answer of 1. So you can't have two x values that have different y values. So this is not a function that is listed here. Now, if all the x values were different, you'd be fine because the y value just depends on the x, so you're okay. The domain is the set of all x's. So when I look at it, you got to write them in ascending order. So we got -2, -1, 4, and 6. I don't need to repeat the 4 twice because it's already there in my set. The range is the set of y values. So go in ascending order again. You got 1, you have 3, and you have 12. Number 2 is exactly the same thing, but the first set, this is your x, so that you're independent, and then you got your y, your dependent value of it. When I look at this set, all my x's are 4, -1, 3, and 0. They're all different, so is this going to be a function? Yes, it is. Okay. The domain, we said, was the set of x's, so we got -1, 0, 3, and 4. And our range is the set of y's, which is -6, -5, 9, and 11. All right. Next set. So 3, 4, and 5 look like graphs to me. Okay, so this is where that idea of that vertical line test is going to come in. Okay, so the vertical line test, the vertical lines go up and down. So you draw in vertical lines. It is a function if the vertical line only touches one time. So when we look at this, no matter where I make a vertical line, it only touches the function one time, so it is a function. The domain is the set of x values, so how far to the right and how far to the left go. So this is 0, 0 here. So we went over 1, 2, 3. So this is over at -3, 0. And then it went to the right, 1, 2, 3, 3, 0. So the domain is all of the x values. So to me, it starts here and goes all the way over to here. So that means the domain goes from -3 to 3. And do you understand why I put the brackets? We learned this when we were doing our interval notation, because those points are included in there, so we use brackets, not parentheses. Good remembered. The y values now, 0, 0 is the smallest y that we have, but if we go up 1, 2, 3, the y value goes up 3, so that's where that's at that point. So my range starts at 0 and will go up to 3, and we use brackets again for our answers. Let's move on to number 4. What test did we say we were going to use? We just said vertical line test. You're correct. Vertical line test goes through. We try it out. Only touches one time, so is it a function or not? Only touches once, so it is a function. The domain is where are the x values. So what is the farthest x value we go on? This goes on forever. It's going to keep going just like this lines keep going. So what is the smallest value that we've learned to know? That is that -infinity. And then it's going to go on forever to this side. So where we at? We're going to infinity that way. So we're covering everything that we need. And our picture goes on forever to right and to the left. And we use parentheses because those aren't numbers. The range now starts at the lowest value is here. And the picture keeps going up, right? It's going to keep extending this way, so it's going to keep going up. So my smallest y value that I have is 2, and it's included, so put in brackets. And we're going all the way up. So I'm like Bud Lightyear says, he's going up to infinity and beyond. So we use the infinity symbol for it. Moving on to number 5, we have the vertical line test again. Okay. Touches only one time, so it is a function. These things continue forever, off to the left, off to the right, so my domain has to go from -infinity to infinity. And then my range looks like this time. This is the highest point, that's the maximum, which is up 1, 2. Okay, so we're at 2 here, and it's going to go down. So in this time, where the highest point is 2, and then we're going to go down to -infinity. You're not going to write it as 2 -infinity. That's silly. It's supposed to be smaller than bigger. So what you need is you need -infinity to 2, and we need a bracket because it's included. So do not do that one. Make sure it's smaller than bigger. All right, the second part of the lesson, okay, is that we're going to evaluate the two different functions. We have two different functions on top here. We have g of x and we have h of x. Okay, you see the different functions that we're going to have here. So in the first one, we're using g of 0. So first off, we have to use the g function. The g function is here. So we want g of 0. This is what letter? They're telling you is x, right? That's what this is. So we're going to take the 0 and we're going to substitute it in for the x value that we need. So in the first one, we're going to set -2 times 0 plus 5. So that's where it went in, right here. Okay. Once we see that, we can evaluate. So that's 0 plus 5. So we get the answer of 5. Put it on the line. Final answer, lock it in. Okay. Number 7, on the other hand, is h of -3. So this is still our x value. We're using the h function this time and substituting it in. So we got to put it in parentheses. So we got -3 squared minus a -3, and then we're adding 4. Okay. Anytime you square a negative number, it becomes positive. So we're going to get 9 here when we evaluate. It's a negative of a negative. So when you see a negative of negative, we know that becomes positive. So we're going to add 3, and then we're going to add 4 on at the end. Add it all together. Final answer, 16. Pretty simple so far, right? Now what happens if we use letters instead? So the m is going to go in place of the x this time, but we're still using the g function. So we got -2, and m goes in there, plus 5. Well, I can't evaluate any further because I have letters. You combine your like terms. This is a -2m, and this is a plus 5. They can't be combined because one has an m, one doesn't. So my final answer is 2m plus 5. Try the next one on your own. Pause the video, try the next one on your own if you want. Otherwise, we'd substitute the w in. You get w squared minus w plus 4. Okay. And what do we get? We're evaluating, so we have w squared minus w plus 4. None of these terms are alike, so you can't combine them for it. We're not going any further than that. We're not solving this. It's not equal to something. Okay, so if it was, then we could attempt to maybe try and factor, but we're not going to. We end there, okay, because it's just evaluating. All right, and then the last one. So now we're substituting in for g into the g function a minus 1. This is our x value. So when we evaluate, we got -2 times what's going to go in here for the x, a minus 1 plus 5. Okay. What do we have to do with that -2? That's right. You said distribute. You are correct. We have -2a plus 2, and then we add the 5 at the end. Is there any terms that we can combine, like terms? I see a +2 and a +5. Combine those. Final answer, -2a, and 5 and 2 make 7. And last but not least, we have the h function this time, and we're substituting in d plus 3 in for x. So we have d plus 3 squared minus, in parentheses, d plus 3, and then we're adding 4. Okay, what do we have to do with this piece? If you said double distribute, or as your algebra teacher teach you, FOIL, this is d plus 3 times a d plus 3. Do not distribute that. Okay, so what do we get? We get d squared plus 3d plus 3d plus 9. Let's continue on. There's a minus sign next to this parentheses. So what do? We have to distribute. It's like a -1 here. So in this case, we have a -1d, and we're minusing 3, and then the +4 comes down. Combined your like terms. The only d squared term I have is here, so that'll go first. All the terms that have d's with them, 3d plus 3d, I'm at 6d, minus 1d. Where am I at? I'm at 5d. And last but not least, we have 9 minus 3 plus 4. We're at 10. So this is the first nice starting lesson on relations and functions. Hopefully it went well, and have a good day.